All right, so are you all able to see the screen which I'm sharing? And are you able to see that clearly?
Yes, sir.
Okay, fine. Fine, so we have around 40 people who are in the class, so we can start today's class. Okay, so I had given you a small program to analyze yesterday, and I'm sure most of you would have done it, right? And some of you have also sent me the output, and they are all correct. So for all those who have not done it or want to validate what is going to be the output for this, it's very simple. The output for this program is something like this. Okay, something like this. I'm sure all of you must have done this or must have analyzed it well. Okay, so this entire thing goes all the way till 7, and then you have 7 plus 1 is equal to 8. All right, so let's look at this program once again on the top, right? And I'm going to do a small variation here. I'm just going to change a little bit of things around here. I'm going to change this to minus, and I'm going to change this to minus here. Now, once I do this, what do you think would be the output now? So this positive sign that I have here, plus, is all going to change into minus, right? And what do you think is going to happen? And here I have changed this plus to minus. Okay, and another thing that I'm doing here is this. So I've made some changes to this program. Just take a minute and try to analyze what these changes are. First change is here, where the increment has been, the decrement has been converted into an increment, right? This is the format in which it was printing. So I have changed from addition to a minus, and here I have changed this from addition to subtraction. Okay, so just take a minute to analyze this, and then I will tell you exactly what will be the output of this program. So while you're analyzing, I'm just removing or erasing this part.
Sir?
Yes?
Sir, the output will be -8 for each answer.
Output will be -8 for each one of them?
Yes, sir.
So what is going to be the first I value? What is going to be the first I value here? All right, let me just make another change. Let me just make another change to this program. Just let me make a small change, another change here. So I have removed this 8 and I'm starting with 1. Okay, now let me know. Now just have a look at this program and let me know. Anyone who can answer would be great. And is it all, you can see, everyone can see the screen clearly, right? Okay. You can take a minute. Yes? Anybody is there who would want to answer this?
-8 minus 1.
8 minus 1. Okay, yes, that's right. So what you're going to have now is there is no 8 now. Here the number is going to start from 0 now. So if you look at the value of I, right? The value of I. Yes, sorry?
8 minus 0.
8 minus 0? 8 minus 0? Are you sure?
Yes, sir.
how will the value 8 come in the first trial? Let's look at it. Here, I is equal to 0, isn't it? I is equal to 0 and j is equal to 1. All right, what I'm going to do is, let me just make another small variation in this, and then we will see what exactly is the output. I'm making another variation. I've changed the sequence. It was I and j, now I'm changing to j and I.
Sir, the
Yes.
output will be -1 for each.
Okay, now if you look at this, the value of I is equal to be, let's do a run for this, okay? So value of I is 0. So first time when this loop starts executing, the value of I is 0 and j is equal to 1. Everybody is clear with that? And it satisfies this condition that I is less than 8. It satisfies this condition, so it will definitely go into this loop. So now it's going to print %d, %d. That means it's going to print the j value and it's going to print the I value. What is the j value here? It's 1. So it's going to print the j value is going to get substituted here, and the I value is going to get substituted here. What is the I value here? 0. Right? What is I minus j? What is I minus j? So I minus j will be -1, isn't it? I minus j will be -1. So this actually is incorrect. So let's correct it. So if I write j minus 1 here, j minus I, then I think it works. So if I do j minus I, the value of j is 1 and the value of I here is 0. So 1 minus 0 is how much? 1 minus 0 is 1. So this makes sense now. This makes sense, right? So now what's going to happen is it's going again to this for loop, and now this would have triggered. So that means this expression would have triggered. So the value of I is incremented by 1. So what was the value of I? The value of I was 0. Now that changes to 1, and the value of j, which was 1, now changes to, the value of j changes from 1 to 2. So it's going to check for this condition. Is the value of I less than 8? Yes, the value of I is less than 8 because my value has changed to 1. So it will go into this loop once again. Right, now when it goes into this loop, what is going to get printed first here? The value of j is going to get printed. What is my value of j now? What is the new value of j? 2. Perfect. What is the new value of I? The new value of I is 1. Right. What is j minus I? 2 minus 1, which is equal to 1. So now this, both of these, the statements are correct. So whatever changes we made in our program fits in well now with the output. Now what's going to happen is there is going to be an increment again, right? So what is the increment? So the value of I is going to change from 1 to 2, and the value of j is going to change from 2 to 3. So what is going to get printed? 3 minus 2 is equal to 1. Similarly, we'll keep going to 7 minus 6 is equal to 1. And finally, 8 minus 7 is equal to 1, because this value of I is 7. So when it actually checks for I is 7, it is satisfied. But when the I value is 8, then this loop exits. That means till the I value is 7, this loop will keep getting executed. As soon as the I value becomes 8, I is less than 8? No, it is not less than 8. So this condition does not hold good. So this loop will stop executing. So what will get printed is only till I7. So your output will be 1 minus 0 is equal to 1, 2 minus 1 is equal to 1, and this appears to be correct. So whatever changes we made in our program now works well. Okay, so this was, you have actually understood how the for loop works, right? So 3 expressions, expression 1, expression 2, and expression 3. This is the condition which is checked in order to, go and execute the statements in that loop, right? This is where we are initializing, this is where we are incrementing. So this is basically a for loop, right? Now, for loops can be very complicated. For loops can be very complicated. So for example, we can have a lot of scenarios wherein we can have loop within a loop. That means, suppose this is my loop. So here is one set of statement which is basically getting executed in a loop. So this is looping. Right now, inside this, I can have another set of statements which will be a loop inside that loop. Okay, so you will have this outer loop and then you have an inner loop. So basically, this is looping, and inside this loop you have another loop. So we can have n number of loops. That means you can have one loop, and inside that you can have another loop, and inside that you can have another loop, and inside that you can have another loop. So you can have lots and lots of loops, but too many loops are not good. Not good. Okay, too many loops will bring about a complexity in your program. It will be difficult for you to understand the program. However, when you're writing real business applications, you can find that people are writing 2 to 3 levels of looping. Okay, especially when you have to work with matrices and all these kind of mathematical problems, then you will realize that you will need to work with minimum of 2 loops. Okay, so this, loop inside a loop. So you can have the inner loop and the outer loop. So when you have loop inside a loop, we call it as nested loop. Okay, we call it as nested loop. That means you're nesting one loop inside another loop. So when the program reaches the inner loop, it will run just like any other statement inside the outer loop. So let's try and see and try to analyze a simple program and see how exactly this loop within a loop works. So I'm going to write a simple program here. I hope all of you can see what I'm writing, right? This is standard stuff, which I'll just quickly go through it. stdio.h, standard stuff when you write a program. Don't need to worry about it right now. Let's go with the main method, right? So here is the main, and now I start my actual loop. So let me declare 2 variables. Now, since I have a loop within a loop, so I can have a for statement with I as one loop, and inside that I can start another loop, but for this I can use the J to control this loop. So I will need 2 variables here, one variable to control the outer loop and the second variable, which is J, to control the inner loop. So in order to have loop inside a loop, let me declare these 2 variables. So I have int I and J. Now this int I and int J are my 2 variables which is going to control the loop. Okay, so let's start writing the first loop. So as usual, my for statement. Now here I'm writing I is equal to 1. Everybody should be clear with what I'm doing here. And I am writing I is less than or equal to 3. Okay, and then I'm incrementing I plus plus. Now, if you look at this, first I value will be 1 once the loop will execute. Then the value of I will get incremented to 2. So it will check here, is 2 less than or equal to 3? Yes. So the second time this loop will run. Then this I will get incremented to 3. So again it will come and check for the third time. So third time the value of I will be 3. So now this 3, is it less than or equal to 3? Yes, it still satisfies. So again a loop is going to run, and then the value of I is going to increment. Now this time the value of I would have become 4. Now again this condition is checked. No, 4 is not less than or equal to 3. So this loop is going to run for how many times? It's going to run for 3 times. Okay, I hope you're clear with this. Now if I change this and just write I is less than 3, then how many times this loop is going to run? This loop is going to run for only 2 times. Okay, because first value when I is 1, first iteration. When the value of I becomes 2, it satisfies this condition and the second iteration. But when the value of I becomes 3, now this condition does not satisfy, because 3 is not less than 3. But 3 is less than and equal to 3, but 3 is not less than 3. So when you're writing loop, by either writing less than or less than equal to, you are basically executing the loop 1. There is a difference of 1. So in this case, the loop will run for 3 times, but if I just write less than, the loop will run for only 2 times. Okay, I hope this is clear. And this is a very important thing to make a note of, because a lot of times we will make a mistake while we're writing the program, just related to less than or less than equal to. So let me just add a print statement here. So let's write a print statement. Print f. Okay. So I'm going to write some statement here. Let me say, let's write the start of iteration. And then let's put the value %d. Okay. This is of the outer loop. This is of the outer loop. Okay. So I'm going to close this here. And then because my outer loop, I am controlling with the variable I. So let me write this I here. So what is going to print here? Every time this loop, the iteration, that means the statement gets executed inside this outer loop, you will have this printed here with the value of I here. So it will print the start of iteration 1 of the outer loop, the start of iteration 2 of the outer loop. Okay, so this is basically my outer loop. Now I'm going to put another statement, another loop inside this. Okay, so now I'm going to put another statement inside this. So here I'm going to run another loop. So for j is equal to 1, now this time I'm going to control the inner loop by j. Now j is equal to 1, right? J is less than equal to 4. Now can somebody tell me how many times this j is going to execute, or how many times this inner loop is going to run?
Sir, 4 times.
Absolutely right.
Sir, 3 times. 4 times, yes, sir.
4 times. Okay, so if I would have written less than 4, then it would have run how many times? 3 times. But what I have done is I have written less than equal to 4. So it's going to run for 4 times. Okay, very good. Now this is basically my inner loop. Okay, this is my inner loop and this is my outer loop. So I'm just marking it. Just marking it. Now let me just give another print statement. So printf. So I can say iteration %d of inner loop. Okay, so I can just close it here, and what I should print in place of %d? J, because j is controlling the inner loop. Okay, and then I'm going to write another print statement here. So let me write another print statement here, right? That is the end of iteration of, or let's say %d of the outer loop. Now let's see, I'll just close this, and here I'm going to put I. Now there is one small thing that we have missed out on. Okay, that is we have not given the brackets properly. So what is going to happen in this scenario is, first this loop is going to get executed. That means for statement, how many statements are there inside for? Only one statement is there. That means this is not going to work as your inner loop, because the for starts here and ends here. Okay, after that this for starts here and ends here and ends here, and after that this is a separate statement. So the reason I purposely did not put the brackets, because see, if you miss a bracket, there's such a big issue here. So what is going to happen here is this will get executed how many times? It will execute. So first what will print? The start of iteration 1 of the outer loop. After that, Second time it will again print the start of iteration 2 of the outer loop, start of iteration 3 of the outer loop. So this will get printed 3 times. After that, this will get printed 4 times, right? And then at the end, this will get printed, the end of iteration %d of the outer loop. Now, what will be the value of I? The value of I will be 3. So this will get printed with value 3 here. So if you look at this, there is no nesting, or there is no nesting of, or basically this is not a inner loop for till now, because I have not included the brackets. So brackets are very important. If you miss out on the brackets, then all these inner loop can cause a lot of problems. Now, where should I put the bracket? That means I should start this outer loop here, right? And where does this outer loop end? This outer loop should end at the last part. Okay, and then after that I should write return and 0 and close the program. So if we don't put these brackets, right, these for statements will not be nested. They will not be nesting. There will not be any nesting of loops, and they will execute just like a normal for statement. But now once I put this for statement, what is going to happen is all these statements are a part of this loop. Okay, so now let's see how this program is going to run. So first, what's going to happen? First, this line is going to get printed for the first time. So outer loop with iteration 1 is going to get printed. After that, it is going here. And now this is going to get printed first. So inner loop iteration 1 is going to get printed. After that, this is going to get incremented, and this is going to be checked, and this condition would have been satisfied. So it will come to this statement second time. So we will have inner 2, again inner 3, inner 4. So 4 times this will get executed, right? After that, what is going to happen? This is going to get printed. That means outer, the end of iteration 1 of outer loop is going to get printed. Are you understanding this? Now what is going to happen? Now it will go again here to check for the value of I, which is 2, right? So second time again this will get printed. So you will have outer 1 with all this, then you will have outer 2 with all this, outer 3 with all this. So how many times this printf statement, how many times this printf statement will get executed? This printf statement will get executed in the entire duration of this program. Can anyone tell me? Can anyone tell me how many times this printf is going to get executed in this entire program?
12 times.
Absolutely. Okay, so with the first iteration of for, this is going to get executed 4 times. Okay, so with the first iteration of the outer loop, this printf, inner printf will get executed 4 times. Then again for the second iteration of the outer loop, again this will get executed 4 times. And then finally for the third iteration of the outer loop, this is going to get printed for another 4 times. So in all, this statement is going to get executed, or it's going to run a total of 12 times. Okay, this statement is going to execute how many times? 4 times. This statement is going to execute how many times? 4 times. So the way this is going to get executed is something like this. So you will have something like this. So outer loop, this is your outer loop. Outer 1, all the inner 4 times. Okay, so inner how many times? 4 times. So you'll have 1, 2, 3, 4 times. Again, we'll have the second iteration. So second iteration of the outer loop, inner again 4 times. And the third iteration of the outer loop, and inner again 4 times. Okay, so this is how this nesting of loops actually work out. So you have to do a lot of practice. You'll have to write a lot of programs. Just give me some time. I'm trying to get some programs for you. Anyway, you'll be doing it in the lab, but I will give you some extra programs from my side so that you can practice at home or in your hostel, wherever you are. I think everybody's at home right now. So you can just practice for yourself. And if you have any problems, you can always ask me. So I will give me 1 or 2 days, and then I will give you some programs to practice the nesting of loops. Now, this concept is very, very important, and you need to be very good at loops. Okay, you should not have any kind of confusion with looping, because in a industry, when you go and write your codes, when you write softwares, maximum 90% of the time you'll be only working with loops, nesting of loops and conditional. So conditional, this is iteration and condition. These are the two things you'll be doing, for the 90% of the time. So it's very important to practice this and understand. Now, just imagine the complexity. Just imagine the complexity if you have the third nesting also. Okay, so if you have the third nesting, then the complexity increases, and you can kind of visualize, right, how the program will become more and more complex. Okay, so if you have, say, 5 nestings, then when you have 5 nestings, just imagine how complex your entire, it is going to be very difficult for you to kind of figure out yourself what is happening in the program when you have too much of nesting. So the nesting should the code for nesting should maximum go till 3 levels, not beyond that. Beyond that, you will forget what's happening in the code yourself. Okay, so we have come to the end of this lesson where we talked about looping. And just to give you a summary of what we have done, so we have talked about looping, how the looping can be used to perform the same set of statements over and over until a specific condition is met, right? What is the point of looping? What is the advantage of looping? The advantage of looping is if you have to write a statement or execute a statement multiple number of times, then you need to write only once and run the loop. That means looping makes your program more concise. So suppose if I want to print like hello, 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 hello 10 times, I have 2 choices. Choice number 1, write printf statements 10 times. Choice number 2, use a for loop or use a while loop, right? And put a condition that executed for 10 times and just write the printf statement once. So what exactly looping does is it makes your program concise. It reduces your code size. Okay, so we have learned the 3 statements: while, do while, and for. Okay, and these are the 3 statements which are used for looping in C. The same concepts will also be applicable to other programming languages. Like if you talk about C++, if you talk about Java and other programming languages, also looping are there. We also use for loop, but the syntax is a little bit here and there. Okay, but the concepts are the same. Now, while the while statement, like if you recall what we did in yesterday's class, the while statement contains one expression, which is the conditional expression, right? And this conditional expression, what it does, it controls the loop. The while statement does not end with a semicolon, whereas the do while statement places its conditional expression at the bottom of the loop, whereas the while statement places the condition on the top of the loop. Okay, the do while statement ends with a semicolon. Now there are 3 expressions in the for statement. I'm just quickly summarizing whatever we have done in yesterday's class and today's class. There are 3 expressions in the for statement. The second expression is the conditional expression. So it's important to understand that when you are writing the for statement, always put the condition in as a second expression. Okay, the for statement should not end with a semicolon. If you end this with a semicolon, this becomes a null statement. Okay, I'll tell you exactly. Null statement means you are not executing any statements, but just running the loop. That means you are adding a delay. Okay, if you're just adding a delay, that means the program will do nothing, but it will execute some lines of code without any purpose. So what is going to happen? It's just adding a bit of delay. Okay, so we will see how these null statements can be used later on, right? Now, you can have multiple expressions combined using comma, right? So in the previous example where we did 1 plus 7 is equal to 8 and 7 minus 6 is equal to 1, in both of these examples we saw that we used multiple expressions here and here. Okay, we used multiple expressions here and here, and we separated the multiple expressions using a comma. And the last part, in a nested loop, inner loop finishes before the outer loop resumes in its iteration in nested loops. That means that first this entire thing, first this will, once it enters here, all the cycles, that means all the iterations for the inner loop will complete, and then the outer loop iterations will happen. So that will result in something like this. So all the 4 iterations of the inner loop will complete, and then the outer loop will happen. Then the second iteration of outer loop, again 4 iterations of inner loop. In the third iteration of the outer loop, again 4 iterations of the inner loop. Okay, so you can make the nesting more and more complex. You can have more iterations inside this, so things can become more and more complex. Okay, so this is the end of your looping. Okay, we need to practice a lot of programs, and that's the whole key to it. But for now, I hope you've understood this entire concept of looping, right? So I will try and get you some more examples, and I'll try and get you some more programs for you to practice. Okay, so what we'll do is we have another lesson, another chapter, or whatever you say. We will start, I will give you the introduction of that particular chapter, but we will continue with the chapter in the next class. So the next chapter that we are going to start today, because we still have around 15 minutes of time, right? In case you have not yet given your attendance, then please write your roll number in the chat box, okay? And when you're writing the roll number, please do not use the last 2 digits or last 3 digits. Siddharth Singh has written only 0-8. Please write your complete roll number, okay? Because there are 2 different sections here, BCA and BSc, and they can have similar last 2 digits, so it becomes confusing. All right, fine. So let's move on to the next bit, okay? And in the next chapter or the next lesson that we're going to learn, we are going to touch upon something which is very, very important. We're going to start using conditional. We are going to start using conditional operators, okay? Conditional operators. So what we have done so far, we did the arithmetic assignment operators, we did the increment decrement operators, we did the postfix and prefix increment and decrement operators, we also did the relational operators. Okay, now in this chapter we are going to do 4 very important operators. Okay, we are going to talk about the first one, the size of operator. This is a very, very important operator. Okay, so I'll tell you exactly what the size of operator is. Then we are going to talk about logical operators. Okay, logical operators. Then we are going to also talk about bit manipulation operators. Bit manipulation. Okay. And then we'll also talk about the conditional operators. They are very, very important operators. Okay, now before we actually start looking at these operators, I just want to ask you whether you know or not, have you, I think you have your computer architecture or computer digital electronics class also, right? Which is happening along with all the other classes. Am I right?
Yes, sir. Digital.
Yes, sir.
Okay.
Yes, sir.
So have you learned? Yeah. Have you learned what is a binary, hexadecimal, decimal, all these number formats in that?
Yes, sir.
Yes, sir.
So do you
Yes, sir.
do you know
Yes, sir.
do you know how to convert a decimal into binary and binary into decimal?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
So everybody knows that, because in order to do bit manipulation operators, we need this concept. We need this concept of how you can convert from decimal to binary and binary to decimal. Is there anyone in the class who has a confusion regarding this conversion from decimal to binary or binary to decimal? If you have, then I can quickly just tell you the techniques of doing so. If you don't, if you know it already, then I will skip that. So if there is anyone who would want me to tell you how to convert a decimal into binary or binary into decimal, please let me know. Otherwise, I will skip this portion and we will continue with the 4 different operators.
Sir, me?
Yeah, can you just write in the chat box, sir, me. Okay. So anyone who wants me to cover it, let me see how many people are there. If there is only one person, I can cover it separately. But if there are more than one, then I can probably quickly cover that today in this class. So I can see there are 1, 2, 3, 4, 5 me's. Okay, fine. So Priyanshu also says, okay, me. All right, so let me start all this in the next class. Okay, we will start these 4 operators in the next class, but before that, let me just give you a simple, example of what exactly these are. Okay, first thing, before we get into the conversion of binary to decimal and all that stuff, numbers can be represented using different formats. Okay, numbers can be represented using different formats. Right, we are very familiar with the decimal format. What is decimal format? In the decimal format, we have numbers from 0 to 9. And using the numbers from 0 to 9, that means how many total numbers are available to us? 10, isn't it? So how many digits are available to us? 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Using the numbers or the digits from 0 to 9, we can represent any number. Whether you want millions, trillions, billions, whatever the size the number is, you can represent it. If you have to represent 183, I use 183. Okay, now this is coming from the decimal format. Now, there are some other formats as well. Okay, one format that we all know of is the binary format. What is this binary format? In the binary format, in the binary format, 10 digits are not available. How many digits are available? Only 2 digits. And what are those digits? 0 and 1. So
0 and 1.
Yeah, so how many digits are available? Only 2. So using 0 and 1, I can represent any number. Okay, I can represent any number. That means 183 also I can represent, and I can represent using only 2 digits, 0 and 1. Now, when you look at the computer understands this binary. Okay, because in the processor, when you are running the processor, the processor and everything, they are digital electronics, right? They work on, can you just mute your microphones, because a little bit of disturbance is coming. So yeah, thank you. So everything works on your voltage, 0 and 1. So if 0 voltage passes, then you can say that it's 0. And when 5 volt passes, you can say 1. So in terms of digital circuitry, everything is represented using binary. Okay, so similarly, you have another number format, and that number format is called as hexadecimal. In the hexadecimal, can anyone tell me how many what you call digits are available? Let's see.
16.
Absolutely. So in the hexadecimal what you call format, you have 16 digits which are available. That means you have 0 to 9. Okay, that is 10. And after that, after 9, you have A, B, C, D, right? All the way till F. So you have 9 digits are going to come from here, and then 10, 11, 12, 13, 14, 16. So using this combination of 0 to 9 plus A, B, C, D, E, F, you can represent any number. Okay, so these are 3 different formats in which numbers can be represented. Okay, now let's skip the hexadecimal right now because our concern is decimal and binary. So it's very important that we have to, it's very important to understand the conversions between them, because your machine understands 0 and 1. We understand decimals. Okay, so we understand this, the machine understands this. So that means whenever we write a number, say 35 or 45, this has to be converted into zeros and ones for the machines to understand. So when the machine gives us a result, so if it gives us a result, say 1010111111, in order to, for us to understand, we have to convert this back into a decimal. Okay, just imagine if the machine is calculating your salary and they give you a salary like 00011011010, right? And you'll think, oh my God, that's a huge salary package that I've got. And they say dollar, but this is in binary format, right? But it actually represents so much of money, but it's actually not, because it's in the binary format. So if you convert it into a decimal format, you'll find that it's a very small number, right? So we have to know exactly how this conversion from a decimal to the binary happens. Okay, so I'm just going to give you an example. Let's take a number 75. Okay, now I will tell you how to convert the 75 into binary. So the first thing, because binary has got 2 digits, okay, it's represented by 0 and 1, so the total number of digits in binary is 2, so 2 will play a very important role. Let's see how to do it. There are 2 methods by which I can convert a decimal into binary. So this is in decimal, and my objective is to convert this into binary. So let's say how to do it. So take this number 75 divided by, binary has got 2 digits, so divided by 2. So what is the quotient and what is the remainder? So the quotient here will be 37, I think, right? 37, yes. So the quotient will be 37, and what is going to be the remainder? The remainder is going to be 1. Right? Now we will take this 37, and divide it again by 2. So when you divide it by 2, what happens? We get 18.5. 18.5. That means, right, 18 will become my quotient, and 0.5, that I bring it to the remainder as 1. Because 18 is 36 and 1 will be left, that 1 will be the remainder. Now this 18, I will go and divide once again by 2. So this time what I get? 9. What is my remainder? 0. Now again,
0.
Again I will take this 9 and I'll divide it by 2. This time what do I get? I get 4, right? And what is my remainder? My remainder is 1.
1.
Very good. So again I will take this 4 and I will divide it by 2 once again. So what do I get? 2 2s are 4. And what is my remainder? My remainder is 0. Everybody is following me? All those guys who had said me. Then I will go again and divide this 2. Okay. Then again I will take this 2 and divide it by 2. So 2 divided by 2, 1. What is the remainder? 0. Now I will take this 1 again here and divide it by 2. So when you have 1 and you divide it by 2, right? What is your quotient? 0, right? And what is the remainder? 1. So once my quotient becomes 0, right? And here my remainder becomes 1. Everybody understood this? Everybody understood what I've done?
Yes, sir.
Yes, sir.
Okay. Now we have got an answer. So the binary number for 75.
Right.
So 75
Bottom
converted
to
into a binary format is take from this bottom,
the
take
last
from this
part.
bottom and
Hello?
go up. So I will first write 1 0 0 1 0 1 1. So 1 0 0 1 0 1 1. Okay, so you go from bottom and go on the top. Are you all able to understand? So you look at this one, this becomes the most significant bit, and this becomes the least significant bit. Most significant bit means the first one, and the least significant bit will be the last one. Now this is your binary number. So if you are getting this many dollar as your salary in binary, it is only 75 rupees or $75. Okay, so this is the binary equivalent of 75. Did you understand? So now we have learned how to convert a decimal number into a binary number. Did you understand, all of you?
Yes, sir.
Okay. The same thing can be done in another way also. Okay. Does anybody know the second method of doing so? Anyone knows it? No? Okay. You want me to tell you or we can skip?
What method, sir?
There is another method of calculating converting a decimal into binary. Okay, let me tell you another method. Okay, so just try to follow what I'm doing, and we will try and see whether we get this answer or not. Okay, so we are trying to convert 75 into a binary number. So let's take our 75 and keep it here. Now we will start with 2. So how much is 2 to the power 0? What is the answer? 2 to the power 0 is how much? 1.
1.
Okay. Is 1 less than 75? Yes. Let's go to 2 to the power 1. How much is 2 to the power 1? 2 to the power 1 is 2. Is 2 less than 75? Yes. 2 to the power 2. 2 to the power 2 is 4. Is 4 less than 75? Yes. Then we have 2 to the power 3, which comes to 8. Is 8 less than 75? Yes. Keep doing till you get a number which is more than 75. So this becomes, after 8 becomes 16, then 2 to the power 5, which becomes 32, and then you have 2 to the power 6, which becomes 64. We're getting close. 2 to the power 7, we get 128. Stop, because our 75 is exceeded now. Okay, now what do we do? So we don't look at this number at all. Now 75 has exceeded which number? Which is the number which is just close to 75? This has exceeded, so the number which is closest to 75 in this sequence is 64. So I'm going to highlight the 64. Okay, then what I'm going to do is I'm going to do 75 minus 64. So what I do is I'll write 64 here just to check whether my calculation is correct or not. Now how much is, and what I'll do is I'll take the 64 and subtract it with 75. So what is the result? The result is 11. Okay, now I'm going to check this 11 and I'm going to find the number which is closest to 11. So if you look at 11, 32 is higher than 11, 16 is higher than 11. So which is the number which is not higher than 11 but closest to 11? So 8. Right, so 8 is the number. So I'm going to highlight this 8. Now what I'm going to do is I'm going to write this 8 here. Okay, now I will take this 11 and I'll subtract 8 from this. So what do I get? I get 3. Now we will check for a number which is closest to 3. That means it should be less than 3 but should not be greater than 3. So which is the number which is less than 3 but not greater than 3? Not 4 but 2. Right? 2 is the closest. So what I'm going to do is I'm going to write 2 here. And now this 2 I'm going to subtract with this 3. So I will get 3 minus 2, which is equal to 1. Is there a number which is closest to 1? Yes, I got the number. What is that number? 1. So I will highlight this. And then we have come to an end. Now, this one also which I have selected. So all the numbers which I have selected here, I have listed it here. Now, can you just add this up and see how much it is coming? 8 plus 2, 10. 10 plus 64 is 74. Plus 1, 75. So whatever we have done is correct. Now let's try to find the binary number. Now all the numbers here in this list, the numbers which you have selected, put 1. Numbers which you did not select, put 0. So this will be 1, this will be 0, this will be 1, and this will be 1. Does this match with what we got here? Yes, it does match. So this is another way of finding the binary number of a decimal number. So I have taught you 2 different ways of converting a decimal number into a binary. Did you understand both the ways?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, perfect.
Yes, sir.
Now, how do you convert a binary back to decimal? All right. So what I do is, let me just write this, erase this entire thing. So I'm going to write 1 0 0 1 0 1 1, and this I need to convert it into decimal. All right. So now we start from, this is 2 to the power 0, right? So this is 2 to the power 0, this is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and 2 to the power 6. So what you have to do here is, you have to take this 1, multiply by 2 to the power 6. Then add this 0 and multiply with 2 to the power 5. Then add this 0 and multiply with 2 to the power 4. Then add 1 and multiply with 2 to the power 3. Then again add 0 and multiply with 2 to the power 2. Then again you add 1 and multiply with 2 to the power 1. And then you again add 1 and multiply with 2 to the power 0. You should get 75. Let's try it. 2 to the 4 to the 8 to 16 to 32. So I get 64 here. So this gives me 64. This is 0. This is 0 plus 2 to the 4 to the 8 plus 0 plus 2 plus 1. 2 to the power 0 is 1. Anything to the power 0 is 1. 1 into 1, 1. How much is this coming? 8 plus 2, 10. 10 plus 1, 11. 11 and 64 is 75. So what is the decimal equivalent of this binary number? It's 75. And since we had done earlier, so we know that the answer is correct. Okay, so everybody is clear with conversion from binary to decimal and decimal to binary?
Yes, sir.
Now, please do not forget, because it is very important, because when we are going to do the, when we are going to talk about these different operators now, the operators that I'm going to talk is shift operator or bitwise operators. Okay, in C, we have something called as bit manipulation operators. We also call it as bitwise operators. So if you have to understand the operations of the bit manipulation operators, you must understand this binary and conversion of binary to decimal, because it will be used there. So since we know now how to convert a binary into decimal and decimal into binary, and what exactly is a binary number format and what's a decimal number format, it will be easy for us to understand bit manipulation operators, which I will start in the next class. So we are almost time. So we can end the class today. If you have any quick question, you can just ask me. Otherwise, if it's a lengthy question, I will discuss it in the next class. If you have no questions, then it's fine. And if everything is okay, we can end here. Yes. Any